want it recursively, we know what it is. It's always the last one plus the next term. Okay, so here we go. We agree that I multiplied right when I multiplied 2 by 3. Okay, now I'm going to subtract these two. Well, I get a 1. There's 1. I get this one minus this one cancels. This one minus this one cancels. All the way down to this one minus this one cancels. Maybe. I don't remember. And on the right hand, I said I have s minus 3s. So I have 1 minus 3 to the n plus 1. Okay. Do one more step there. Do one more step algebra. So 1 minus 3 to the n plus 1 is s times 1 minus 3. If I divide through, I've got 1 minus 3 to the n plus 1 over 1 minus 3 is s. So if I want to add up 1 plus 3 plus 3 to the n, there's my formula. And that's what I needed up here, right?
One minus 3n plus 1 is the first term in the first sequence and the last term in the...
Right, because all the middle terms cancel.
Equals s minus 3.
This minus this. I'm subtracting both sides of the equation.
Okay.
So everything on this side, 1, there's nothing to subtract. 3 minus 3, 3 squared minus 3 squared, everything cancels. And then minus the 3n plus 1, then s minus 3s. Now, I didn't bother to subtract it, get negative 2 for a reason, because I'm looking for a pattern here. And so now I have this divided through by the 1 minus 3, that's my s. So what do we know from that? Let's summarize what that means. What is this? So s was the sum from n equals 1 to infinity, no, n equals 0 to capital N, of 3 to the n, right? That's the left side. 3 to the 0, 3 to the first, 3 to the second, up to 3 to the n. And we figured out that that is equal to 1 minus 3 to the n plus 1 over 1 minus 3.
What exactly are we trying to figure out down here in this
Okay.
left?
So what I'm trying to say is, what I'm trying to figure out is I'm still looking for a pattern for s sub n over here, okay? I'm still looking for a pattern for the nth term. I know what it looks like. It looks like s sub n is 3 to the n minus 1, right? S sub 4 is going to have as a denominator 27. S sub 3 is going to have a denominator of 9. So I know what the new denominator is. And I know there's a 5 out front. Right? So that part's easy and that part's easy. And what I needed was the top part.
You see on the top where you subtracted it, you had the 3 and 3 minus 1 at the top. You got the 3 and plus 1 at the bottom. Where did the 3 and minus 1 go?
Let's forget n for a second. Say it was 1 plus 3 plus 3 squared plus 3 cubed plus 3 to the 4th was s. That's just, so n is, n I'm doing is 4. Then if I multiply it by 3, I have 3 plus 3 squared plus 3 cubed plus 3 to the 4th plus 3 to the 5th equals 3s.
So,
with me? Now subtract. 1, 3 minus 3, this minus this one minus this one. Here goes the n minus first one. This one minus this one. There's nothing to subtract for that, so it's still there. So 1 minus 3 to the 5th over 1 minus 3 is what S turns out to be. And so, yeah, the 3 to the n minus 1, there was 1 back here. It's the 1 before this one, right?
what gave you confirmation to want to multiply by 3 right there?
Pardon?
What made you want to multiply 3 right there? What gave it away?
Well, that's just slick trick 37. I'm trying to derive the formula for you, and I want to do it with numbers first. It doesn't matter if you would always multiply by whatever the power, the thing you're raising to the power is, because if I multiply this by 4, none of these would have canceled when I subtracted, right?
Okay. That makes sense.
Okay, so now the question was, what goes here? And I now know that what goes there is going to be messy here, fit it in. But by figuring this out, it's going to be 1 minus, but let's see, what's the power that I want here? I think it's that. Let's check. If I put 2 in, I get 1 minus 3 to the first over 1 minus 3. I get 1 out. Oops. Wanted to agree 1 minus 3. Wanted to agree with E. So if I put 2 into this one, I get 2. 1 minus 9 over 1 minus 3 is -8 over -2 is 4. Hey, that's A2. If I put 3 in, I get 1 minus 3 cubed over 1 minus 3, which is 1 minus 27 over -2, which is 13. Okay, so I worked really, really hard to try to figure out what those top numbers are. And anybody that tried this problem, it doesn't matter how you work it out, somehow you have to figure out what that summation is, right? And you can do it different ways. There are other ways to do it, but I finally found a formula for this. But look, that was tough, right? We don't want to do that every time. But